Hello to everyone. This is next challenge of August. I would like to share you some thoughts about problem. Here we're discussing seismic refraction data and ERT. The first part of request was about how to choose trigger time correctly if there is a problem with triggering system. So there is options in photograph sub menu. There is the trigger time or start time can be corrected by reciprocity principle. Also, it's possible to correct trigger times with start times, but better to use this option, reciprocity data, and it should be reciprocity points in your data set. It's when you can have a receiver, phone, and source point in the same position but in different order. In this case, first break should be the same. So if you have a lot of such time, you will have a good correction. But the problem is we have relative estimates from this procedure of trigger time. So it's corrected, but level can be wrong. So I can recommend another trick. If your geometry is okay and topography elevation is inputted, you can use a special trick for finding trigger time. For example, very often we can see in our data, let's see, we can see air wave. For example, I can think about this. But this part of seismogram is air wave. I'm not sure. Usually, air wave has a different frequency from another signal, and it's make it easy to find it. So there is a procedure, some function for finding derivative of signal. If we apply this procedure, we can see high frequencies better. It's right here. And now we can see something here. It's probably air wave. We should check it because air wave is 0.34 kilometer per second. Yes, it's something like this. And when I use this operation, I can see in this small window estimation of trigger time. So it's about 10 milliseconds. And here we have a 7. But of course, I did now, it's very roughly, we should choose the way of this tool from phase to phase or from extreme to extreme. And this procedure is much better when we have a long way. So this line crosses several traces, and then it's give good accuracy. So this is the way how they can find trigger. Of course, if we have a GAFON near source point, so we can analyze this first trace, closest trace, and when we see extremum, very high peak on this trace, it will be trigger time. So this is my advice. If you see error wave, you can choose it. Sometimes you can use these correction functions, and also you can analyze first spacings, first closest offset geophones for apparent velocity. It's supposedly for most cases shouldn't be very different. As it here, it's about 0.3. And for my opinion, it's maybe too small. Maybe it's a little bigger. Anyway, I'm going to go to next part of question. It was regarding ERT. So in the same place, it was ERT carried out in the same line, the same geophone positions with dipole array. First of all, there is some topography elevation, but not fine step, and we can use it as is. So for using topography with different number of electrodes, we can use Control X. Indeed. Now we have it with interpolation between points, of course, because we have only 5 topographic points. And now we have our section with topography. It's not so strong changing, but anyway. What I can say about this pseudo section, about this data? First, let's check it in vertical electrical sounding mode. This is several soundings around point I clicked. So it looks like 1 layer, 2 layer, and 3 layer model. What is the problem in this model? This is a high resistivity first layer, and second layer, second and third, has a very little contrast between. This is a big problem for ERT to resolve such layer, because we have this screen of high resistivity layer, and it's not easy to find model under this screen. So we can see how our 1D model looks like. We can copy to our section to compare. Okay, now let's check the data. So I see some spikes, but not so huge. So we can use another way of plotting. Remove data we don't like. It's no problem to involve this data inversion. Let's do without it to be sure that everything is okay. Okay, now I can see partly clean data and I can test some inversion. First of all, I would like to see some approximation of error distribution. Oh, that's me. Let me do very simple and very formal inversion. First, some settings from another project. It's very high vertical smoothness. This is thing I told about. So it's very gradient contrast border here, and here we can see normally our section. We can see some traces of this second layer, but it's not so good. Okay, now let's see distribution of errors. So this here is some errors anyway, and this is how distribution looks like. Let's make limitation 4%, 5, and remove all records which doesn't fit this constraint. Okay, now I can try this normal inversion. I will do Occam robust inversion. And I would like to see what's it give to me. And let's make flatness ratio 0.2 because it's definitely horizontally layered model. Everywhere is just changing first layer. Okay, this is what they got. Let's see model, averaged model. And yes, it looks like 1D. This part section, if you see this yellow cloud, it's changing. And we have here no sensitivity. So we can do with this part whatever we want. So I put this model to the buffer. It has a very good RMS. Let's try some tricks. For example, we can use layered theorem, make our model more horizontally layered. See what happens. This one looks better. I suppose I can see now two borders. Yes, this. Let's compare it. It's very close, but some difference. This middle part. Okay, I think this is good enough. And now we can maybe try to add seismic data and try joint inversion. So there is already picked data from project I know it at the start of this video lesson. This is data. This suggests me because there is data in distances, and here is in projections, and we have a topography. It suggests me to make projection of seismic data. This connecting point 0, as I understand, and where is data? Travel time curves. So I can choose some joint inversion, seismic data as is here, and I'll try to find model, but I think now I can turn off this kind of optimization, and I should set up a constraint for velocities. Right. Yeah. Okay, let's try it. Okay, this is enough. So I will cut by race, and this is how my seismic section looks like. Let's make it the same size. So we only see this border. Here it is red. Here is blue. Some correlation between, because we couldn't reach with seismic this part, but could do it and do it with RT. Okay, that's buffer. And maybe try to use another type cross gradient inversion without CC criteria. Why result in the middle and the part of section so different? This is very easy to answer this question. This is because sensitivity is very low, as well as resolution. Yeah. Okay, let's see what is seismic. Yeah, this is very close to first result, but this one may be better. So this thing, red and blue here, I can see it easily. I don't think it's something local object. Oops. Okay, let's put it in Woofer and let's compare every result. So, yeah, this is not so different, but yeah, there is some different details, especially in this part of section. So, this is my answer for two questions. Thank you very much for your attention and bye bye.